Okay, in this lesson we're going to be looking at the difference between linear, quadratic, and exponential regressions from a table. So we're going to be looking at our y values. The y values of linear functions have constants on the first differences. So difference means subtraction. So we're going to take the y value and subtract it from the previous y value. If the x values are evenly spaced, so if they're evenly spaced, if the first difference is constant, which means the same throughout, then that would be linear. So for example, this here, notice we're subtracting the y values from each other and we get 8 for every single one of them. So that would be linear. Okay, so the y values of quadratic have a constant on the second difference. If the x values are evenly spaced. So an example would be right here. So notice we subtract the first differences between the y's. We don't get a constant, but then we do it again, and we get a constant. So that would be quadratic. The y values of exponential functions have a common ratio if the x values are evenly spaced. So notice we're dividing. So ratio means we're dividing fractions. So we're taking the y value divided by the previous y value. And notice when we keep doing that, we get a common ratio of 1/2 there. So that would be considered exponential. Okay, so we're going to look at our first example. We're going to analyze the table to determine whether it's linear, quadratic, or exponential. And then we're going to use that regression on the calculator to find the equation. So first, I always recommend looking at the differences first. So I'm going to subtract. So that's going to be 27 minus 1, which would be 26. 729 minus 27, which would be 702. 19,683 minus 729. That would be 18,954. So we know it's not linear. So x to linear. And then we'll keep going on the difference. 702 minus 26 would be 676. And then 18,954 minus 702. That would be 18,252. So those are not the same. So that's an x to quadratic. And then the other one is doing the ratio. So we're looking at these. I'm going to do 27 divided by 1, which is 27. I'm going to do 729 divided by 27, which would be 27. And 19,683 divided by 729, which would also be 27. And also notice that these x's are evenly spaced. Okay, so we know that it would be exponential. So we're going to insert the data into the calculator. So, oops. So we're going to go to Stat, Edit. Remember, you can go up and clear out your list. The x values were 2, 5, 8, and 11. And then the y's were 1, 27, 729, and 19,683. So we're going to do Stat, Calc, Exponential. If you remember, you can go down or up. It's at 0. And then we're going to calculate. So part A says what function? We already classified it as exponential because they have a common ratio. And then we just found that equation. It's y equals a was 0.111. The base was 3 and then to the x power. we're going to sketch the scatter plot containing the regression equation. So if you go back to your calculator, remember stat calc exponential 0. I can store that equation so that way I'm not rounding. So vars over enter. And then zoom. In order to see all of the data points, zoom 9 will get you there. So we're sketching that on our paper. Hang on. There we go. So we'll just draw it comparably to what we have. So that would be similar to what is on our calculator. So if you want to, you could plot the points. Okay, let's move on. So example 2, a regular polygon with a 5 meter long apothem has an area of 25 meters squared when the perimeter is 10 meters, and an area of 37.5 meters squared when the perimeter is 15 meters, and the area of a 15 meter squared when the perimeter is 20 meters. And the last one, an area of 62.5 meters squared when the perimeter is 25 meters. So we're going to fill in the table. Notice it already labeled it. So our X would be perimeter, our Y would be area. So we're going to fill in. So first one, perimeter was 10 when the area was 25, 15, 37.5, 20, 50, and 25 was 62.5. Okay, so it says create a table organizing the data from the description, analyze the table to determine whether it's linear, quadratic, or exponential. So let's look at the y values and the difference. So 37.5 minus 25, that would be 12.5. And then we'll do 50 minus 37.5, that would be 12.5. It's looking good. So subtract 62.5 from 50, or 50 from 62.5, and you should get 12.5. So notice that those are all constant, and it's evenly distributed on the x. So that means this would be linear. We're going to use the regression on the calculator, and then we're going to end up having to sketch the graph. So let's go ahead and go to the calculator and insert our data. Stat edit. Again, you can clear out your list. So 10, 15, 20, 25, and then 25, 37.5, 50, 62.5. Check your points. And then since we found it to be linear, we're going to go stat calc linear's number 4. I'm going to go ahead and store my equation also. So vars over enter. And we have our equation. So it should be y equals a was 2.5 x, and then our b was 0. So we don't actually have to put that there. So we need to go back. The reason for linear here was because the first differences were constant. Okay, so see, we're going to look at our calculator graph. So go to graph. If you can't see it, remember zoom 9 will adjust your window so you can see your points, and then clearly that line goes straight through those points. So we're sketching it. Just to save some time here, I'm just kind of sketching it very similar to what I have on my calculator, so that way we can finish up the lesson. Okay, let's flip on over. Now we're going to be looking at the coefficient of determination, which is your R squared. That will also help you with knowing what type of regression you have. So the coefficient of determination is represented as your R squared, which is the it quantifies the strength of the regression model. All common regression models include that R squared, which indicates how good of a fit an equation is for the set of data. However, not all regression types include R, which is the correlation coefficient, because R is measuring the strength of linear relationships. So R squared values are always between 0 and 1. The closer R squared is to 0, the poorer the fit is. The closer R squared is to 1, the better the fit is likely to be. The value of R squared doesn't always tell the whole story, but can be used in conjunction with graphing scatter plots and human judgment to determine that best function. So what we're going to do on example 3 is we're going to use the regression function on the calculator to calculate linear, quadratic, exponential for this data set that we have. For each type, we're going to graph the scatter plot and see which one looks the best, but also looking at our R squared, which is that coefficient of determination. So I'm going to go ahead and go to my calculator. I'm going to go to Stat, Edit. I'm going to type in my points, so 5, 12, 25, 42, and then 73, 40.8, 33, and 124.8. Now notice our X values are not evenly distributed here, which is another reason we would want to use that R squared. So I'm going to find linear, quadratic, and exponential. So we're going to do one at a time. Now, before we get started, make sure your R's are turned on. So I need to go to second and then catalog, which is 0. I need to go all the way, hold your down arrow key to diagnostic. Diagnostic on. Press enter and press enter. It says done. Okay, so first I want to find linear. Stat, calc, linear's 4. I'm going to go ahead and store this equation so that way I can graph and write my equation at the same time. So vars over enter, enter. Calculate. Okay, so let's write down our equation. So linear would be y equals 1.534x plus 35.696. That R squared equaled 0.358. And then if we go back, there's our information, go to the graph. Let's go ahead and go to Zoom 9. And we're going to sketch that on our paper. So again, to save time, I'm just going to kind of sketch it from my calculator. I'm not going to look at the lines right now. So it looks similar to that. Okay, so now let's find quadratic. So I'm going to go back to the calculator. This time I'm going to do stat, calc, quadratic is 5. I'm going to store my new equation, so vars over enter, enter, calculate. So notice here we have A, B, and C that we're plugging in, and then notice it also gives me the R squared. So my equation would be y equals 0.2x squared minus 8x plus 108, that r squared equaled 1. So if you remember, the closer r squared is to 1, the better fit. So if we go back to our calculator, look at graph, we can see most all of them. So zoom 9, notice it goes through every single point, which is why r squared's 1. So I'm going to plot those points. So we have that parabola there. And then we're going to do the exponential one. So going back to the calculator, we're doing stat, calc, exponential. Remember 0, you can either go up or go down to 0 or just use the 0 button. I'm going to store my equation so I can see the graph. So bars over enter, calculate. There's my equation. Notice my r squared is 0.207. And then if we go back to the calculator to see the graph, press graph. We can see that it's not a good fit for those data points. So again, we're going to sketch that. So that's your exponential there. So it says, what type of function best fits the data? Clearly quadratic. The reason is because that coefficient of determination, which is your r squared, is 1. So remember, the closer it is to 1, the better fit it would be. Okay? So if you have any questions, so if your x values are evenly distributed, you can find, by looking at the differences or the common ratio, you can determine what type of regression you have, or you can use this coefficient determination to help you to figure out what would be the best fit. If you have any questions, please let me know.